This is the one I want to go through. Section 5 in Unit 2 or Chapter 2, whatever. And this is really, as the name suggests here, just we're going to take right triangles and see how we can use them. Pretty much this whole year, we've just been working with right triangles, right? What can we do with them? What sorts of applications of this are there? Can you guys imagine what some might be? What has been the guiding purpose of last semester? What was that?
Find out how tall that is.
Damn it, that's right. How tall is the flagpole, right? And we wanted to use some triangles to do that. And so, what else might we be able to, thinking creatively with what we've learned? How else might we be able to apply it? So, before I push you further, James, why don't you explain to me how we would use trig to figure out the height of the flagpole? What was
I'm explaining things out loud, and I'm better at writing them down.
Mm-hmm. Well, who's good at explaining things out loud? Me? Should I do it?
Sure.
Yeah. You could imagine measuring the distance between you and the flagpole, and then taking the goniometer and getting the angle between that line between you and the goniometer and the top of the flagpole, or the line between you and the flagpole and the top of the flagpole, getting that angle, and then using a trig function to determine what the height of that flagpole was. So, for example, let's make a little flagpole, and here we stand. Here's our eye. Looks like a reptilian eye or something. And we know that this distance, we'll just call it some distance d, and then we have, with the goniometer, we get angle theta, and we could say something like, we want to know this height, h, so opposite over adjacent is going to be tangent. So tangent of theta equals h over d, and thus we know that d times the tangent of theta is going to equal our height, right? For example, that would be one application of trigonometry. Figuring out how, and based purely on the fact that that's a right triangle. That's convenient. There's only so many times you need to figure out how tall a flagpole is. What other ways might we be able to bend this sort of thing to useful purpose?
Is the 3, 4, 5 triangle? Is that what's called?
There's a Pythagorean triangles. Yeah.
Yeah. Is that the right triangle?
It is a right triangle.
So yeah, you can use that for what carpenters use that for.
All right. So we have Pythagorean triangles, and yes, and she wants to be a carpenter with that. So that is a triangle that has 3, 4, 5, right? And there's a host of there's an infinite number of these Pythagorean triangles that can fit inside of a right triangle. What else? What else can we do? Any other things? Can we use it to figure out say we are standing on the ground and we see an airplane We want to know how high the airplane is. Could we use this map to do that? What the altitude of an airplane is? What do you think? Maybe? I don't know exactly how. Huh? What?
Well, it depends if like the ground and the air. Well, I guess it doesn't have to be flat. I guess if you were on like a hilly surface, that would make it harder.
Okay, maybe. Depending on the geography. What else? What do you think?
I think you could, but the biggest issue is finding out what the distance or height is.
Okay.
Because you need to know at least one of those.
Okay. So the distance from where the airplane is up above the ground versus
And airplanes move quite fast. So
they do. Yeah. Yeah, they do. I'm eating lunch here. We need some kind of information beyond just the angle that it's making with the ground. Okay? Maybe there is some application. In fact, there is. We're gonna talk about how, like, what are those called at airports? The towers, the air traffic control towers. How air traffic control towers are able to monitor airplanes in the sky and know fairly accurately what their height is, independent of the information that the airplane itself is sending back to them. I'm going to go through a bunch of different applications of this stuff. And the homework assignment that I gave you for this unit expands upon some of the basic math applications that we're going to talk about. So first, let's talk about the concept of bearing. Direction. Bearing is what direction means. I want to head in a certain direction. When I say bearing, I mean north, south, east, and west. All right? This is how bearing is expressed out in the real world. So, two methods. The first method is just an angle. When someone just gives you an angle, that is a bearing. So I've seen an object, a UFO, Commander, there's a UFO at 164 degrees. Well, that means that it is 164 degrees from due north. So rather than, up until this point, our zero has always been right here, huh? And we've measured angles in that direction, right? Like this would have been, 45, this would have been 90, this is 180, etc. Well, with bearing, this reference point is due north, all right? So, and we go clockwise rather than counterclockwise with bearing. So 164 degrees would be down here. Pretty close to south, right? Because we know that north, south, east, and California. All right. Any questions on that? It's just a basic definition of bearing. So here's a little word problem. Take a look at it. Does anyone want to try to take a crack at it? Let's look at it. Radar stations A and B are on an east-west line, 3.7 kilometers apart. So step one in any word problem that you come across, start mapping things out. Even in my crazy 8-page word problems that I give you, there should be some sort of mathematical model that you should be able to map out and extract, even if I'm trying to hide it in all that text. So here's a radar station, A. It's at the top of a air traffic control tower. Here's another one, B. And what does it tell us? That they're separated by 3.7 kilometers. All right. Station A detects a plane. Here it is. All right. At point C. We put like windows for everybody so they can see. And on a bearing of 61 degrees. So this is north for A, and this is north for B. For A, it's on a bearing of 61 degrees. Station B simultaneously detects the same plane on a bearing of 331. So from north, it would go 90, 180, 270, and then what did it say? 331. So this is 331 degrees. Find the distance from A to C. How far away is airplane A or airplane C from A? Oh man, it's pretty much all the information they've given us, isn't it? Everything they gave us is on the map. Well, let's think about this for a second. What do we think that angle is? This angle. Can we figure out what that angle is? I don't know. All right. Everyone follow that? So here, oops. I'm going to erase my drawing and use theirs, which is a little bit cleaner. Turns out, exactly, is this what you were saying? I think it was, yeah. So we know that if this was 61, this angle here has got to be 29. And if this angle was 331, that means 270 from 331 is 61 degrees there. Pretty convenient. They picked some convenient numbers for us because 29 plus 61 is what? Yeah, yeah. Let's just smile at you. 90. Nope, it's 90. It's 90. These two are 90, which is convenient because a triangle has 180, which means this is going to be 90 degrees here, right? Convenient. It's convenient. Yeah. Okay. So now what do we do? Huh? We want to know what B is. We're looking for B. The distance from A to C. What is the distance from A to C? Does anyone want to take a stab at it? Sure. Should I do it? Well, what do we know here? We've got this angle. We have this angle. We could do it out of either angle. We have the distance between them. So we have two pieces of information. The third is that this is 90 degrees. So you only need three pieces of information to determine a triangle. So we should be able to figure out everything else using trig functions, right? Do you want me to do it with 29 or 61? 61. All right. So looking in this direction, we have hypotenuse, and this is going to be opposite, right? So what relates the opposite to the hypotenuse? Guys, it's been a little while. Sine, yeah. Sine equals opposite over hypotenuse. Remember? SOHCAHTOA. 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 We had another one too. Remind me what it was again? SOAX, TOAX.
Yes. Yeah.
SOCAX, TOAX or something?
Yes.
Yeah, I know. I feel the same way. Anyways, sine is opposite over hypotenuse. So we know that the sine of 61 degrees is going to equal opposite over hypotenuse. It's going to equal b over 3.7 kilometers. Thus, b equals 3.7 kilometers times the sine of 61 degrees. And for sine of 61 degrees, you just pop it into your calculator and it'll tell you what the sine of 61 degrees is. Or we could look it up in our lookup table and pick a value for sine of 60 and maybe add or subtract a little bit depending on where it is in the curve. Right? Multiply that by 3.7 kilometers and it'll give us the distance b between the airplane and the radar tower. You guys see how I did that? Think you could do it yourself? Maybe. Try.
It'll just take a little bit more time.
Yeah.
Getting the coordinates of it.
I haven't seen you guys in like 2 months.
Yeah,
It's been a long time. Maybe a month. When did I see you guys off?
before Christmas.
A month. All right. But Hope got the essential step there, which was great. Let's give Hope a little recognition. You want more than that?
What?
You want more than that?
No, I definitely think Ravenclaw should
She should get more than that?
I think it should be at least 2. Yeah. I
Okay.
think 2.
Cool.
Ravenclaw's like 30 points behind. It doesn't hurt to get
Oh, yeah, okay, cool.
Yeah, but that doesn't mean you have to like pass them out willy-nilly.
I'm not handing stuff out willy-nilly. She worked for it. All right. Okay. So, right angles are formed. And whatever. We went through that.
Lance is at school. He's just not here.
Is he? I sent an email. They use cosine, but I bet you. So let's see here. Who's got a calculator? I had b equals 3.7 times the sine of 61 degrees. Can we see if their value equals my value? Somebody do. Who's going to do the sine? You do it. Oh, you did it?
Yeah.
What did you get for sine?
So you type in 61 and then you hit sign, right?
Yeah.
Okay, yeah. So 0.8746.
Times 3.7. Gesundheit.
3.23609.
Okay, that's good. 3.26. Now what about this one? Cosine 29 times 3.7. It's nuts. Anyone wants to mix nuts?
3 point, yeah, it's the same.
It's the same thing.
Same gosh darn.
Holy cow. That is incredible. More than one way to put on your socks. All right. Caution. A correctly labeled sketch is crucial. I love it. Flying warning here. When solving bearing applications, some of the necessary information is often not directly stated in the problem, and can be determined only from the sketch.
No way.
Yeah, absolutely. Absolutely. Visual arts is important. Eager young minds. Learning how to sketch and drawing an idea is important. All right. Another one. The second method for bearing is, I actually think, a little more common. I don't know. That's completely smoke out of my ass. I'm not sure which is more common at all. I don't know which is more common, but here the two of them are. The second of them involves the north, south, east, west directions, and always uses an acute angle. So here's how this goes. If it's in quadrant 1, you use that convention. If it's in quadrant 4, you use that. If it's in quadrant 3, you use that. And if it's in quadrant 2, you use that. Does that make sense? Yeah. So if it's in 1 or 2, it's going to be a north bearing. And that makes sense. Like, here's your compass, north, south, east, California. And if it's north, it's either going to be over here or whatever. And it'll be either east or west of north. And if it's south, it's either east or west of south.
East or California?
Or California. East or California of south. That's right. I'm 32 degrees California of south. Heading for the border. All right. You guys got this one down, basically? And this is a little bit odd because it's always, the reference angle is either clockwise or counterclockwise in relationship to the north-south line. All right. So here it's measuring it clockwise. Here it's measuring it counterclockwise. This is clockwise and counterclockwise and clockwise.
So how it's written at the bottom is how you would always write it. You wouldn't write like NW 52 degrees. You would write N 52 degrees W.
Mm-hmm.
Okay.
Yeah. And it's southerly heading 40 degrees west.
Okay. So if it's written like that, then we know it's doing it this way. But if it's just an angle in general, then it's the other way.
Mm-hmm.
Okay.
And the other thing that'll be indicative is this way the number's always going to be less than 90, right?
So what would it be if it was exactly 90 degrees?
North, south. Oh, 90, it would be just west, or 90, yeah, it would just be west, or east.
Okay.
Yeah, I guess you could make it, so I guess then it becomes redundant, like north 90 degrees west would be the same as south 90 degrees west. Mm-hmm. Yeah. Now the problem ship on a boat. Set sail. Anyone been on a boat out in the ocean? Big one? You have? What was that like?
It was when I was a lot younger, but I went with my parents on a
Cruise?
well, not quite like as big as a cruise, but
Well, I don't know how big this one is, but it's making some pretty good time. 22 knots is not screwing around. Boat's moving. Ship leaves port and sails on a bearing of north 47 degrees east. So let's do it. Here we go. North 47 degrees east for 3.5 hours. 3.5 hours. And then it turns and sails on a bearing of south, 43 degrees east. For 4 hours. If the ship's rate is 22 nautical miles per hour, find the distance that the ship is from port. Okay? So, 22 knots. Jeez. Anybody want to attempt this one? Any red claws going up to it? Ha! So what distance do we want to know? Somebody go up and label that. Just take it in small bits. Here's a marker.
So
Gryffindor for
from
3.
there to there.
That's it.
Yeah.
All right. Cool. Let's call it a
D.
Yeah, D.
Distance.
Sweet. I like it.
Good?
Yeah. So, how far did it go on its first leg of the tour? What's your name, Owen?
Yeah.
Yeah. What do you think?
Oh, don't even. No.
So wouldn't you just
Well,
have to multiply?
here, brother. Like, what if you were in a car?
Yeah.
And you were going 22 miles an hour, and you did that for 4 hours. How far would you have gone? Sweet. How'd you do that?
That's added position.
Okay, added what?
22 4 times. So
Okay.
22 times 4.
Yeah. All right. And so, how would you apply that to what we're talking about here? So he's going for 33.5 hours in this first direction at 22 nautical miles per hour. How many nautical miles is he going to travel? If he's going 22 nautical miles per hour, and he does that for 3.5 hours.
88 hours.
Well, it would be close to 88.
Oh, I need to say, oh.
Yeah, I got you on the spot, man.
Man,
You can do it. I'm sure you've got multiplication in your tool bag.
yeah, I do. It's just, okay, so.
Yeah, how would you 3.5 times 22? What's a strategy for doing that in your head?
I can't even remember.
So I would personally do like the 3 and the 22. So then you know what that is, 66.
Yeah.
And then the 5, what's half of 22?
Oh,
11. You can just add the 11.
That's definitely an easy, straightforward way of doing that. So 77 miles. Mars, I'm going to give you another point for putting that up there. You did that.
Huh?
Yeah, go ahead. Put 77 up there near 3.5 hours. So we know how long that side is.
But this bit is
Yeah.
this, but this bit's not. Or is
Nope.
it? Right, okay. So this bit is 77.
7. Yep.
Okay. Mhm.
Yeah, that's right.
Great. And then this one's going to
Yeah, gonna be.
88.
Do it. Do it.
88.
Okay. So, what is left to us here? Aren't you racking up some points? Mars, that was a 3, and we'll give you 2 for that other one. And Owen is in Ravenclaw. All right, Owen, we'll put you under the auspices of hope, and we'll give you. That's pretty brave. I had you right on the spot. Points for that. Yeah,
Not bad.
yeah, banner day here.
You'll pass Slytherin, but I don't know if you'll get past Gryffindor.
Wow.
That's true. That's true. I don't think we'll ever get
What's
That's
next
been
here?
points, like, every time.
Molly, you're a Slytherin. You don't like these points getting handed out willy-nilly to all these people. Slytherin is should be the one true dominant house in all of this. What's your response?
What was the question?
Good.
I agree
Good.
with that.
Focus on what the actual question is. That's right. What's next? What do? We want to know this distance.
You have to find out the length of, like, if you're looking at that as two triangles connected, you have to find out, I guess that would be A or B.
Okay.
Whoa, we're not going A, B, or C, but you need to find out the vertical line.
Okay, so you're thinking about it like this, huh?
Yeah.
Okay. Awesome. Absolutely solid way to approach this problem. Absolutely solid way. Yes.
Could you label which side is the opposite hypotenuse?
Yeah. Come and do it. You do tell me what you want to see. Here's some other colors.
I was wondering if you could label it because I don't I feel like I know, but I want to see which side is which.
Which is a hypotenuse. If we do what she's telling us to do, then these will be the hypotenuse.
I know that would be the hypotenuse.
Yeah, and doing it her way, which I'm just like I might be giving it away here, but her way is not the only way, but it is the Slytherin way, and so it is inherently the best.
So, would it have to be, is it necessarily 90 degrees though? How do we know that for certain?
Great question. How do we know that is 90 degrees? And do we know that is 90 degrees?
Well, if we're using no, you go ahead. If we're using the horizon as our, like...
Is it the horizon? No, we're looking, this is not from the sky. We're looking down on this.
Oh, right, okay.
We're looking down on this. This is a ship.
Then I have no idea.
In fact, that's correct. We have no idea. We have no idea that this is actually a right angle. And in truth, it is, for this to be a right angle, this angle would have to be the same as that angle. And they're not. They're just very close to one another. Yeah. So that was a good thought. It was a thought based upon saying, oh, this like kind of weird line across there looks vaguely right, but that is incorrect. It is not right. What are we going to do? What else on here can we label that we know? What do we know about this?
So the like this bit is 90, right?
No, we don't know that this is 90. In fact, it's not. If it were 90, then these would be 90.
Oh, right. Okay.
Yeah, let me maybe make this drawing a little bit more accurate.
Oh, sorry.
Electric. Okay. That's probably a little closer to reality.
Okay.
What else do we know there?
Okay, so this is. So is this? Where's? Wait. No.
This is tricky, but it's like right there. It's right
So-
there in front of you. Well, what other things are there to label on here? What other like segments are there to label? And just start putting. Why don't you just start putting variables where we can have things that can get labeled?
Where? I don't know.
Well, what things are there to get labeled? There's the only things that can get labeled are angles and line lengths, right?
Mm-hmm.
Yeah. So what are the angles and line lengths that we have yet to fill in?
Wait, so this one goes to this?
Mm-hmm.
Okay.
Yeah.
So we don't have
this one or this one?
We don't have this one. We don't have this one. We don't have this one, nor do we have this one.
Yeah.
Right?
Mhm.
Or do we have this one?
Yeah. Right.
Okay.
Mm,
We haven't labeled any of those.
Right.
But do we know any of those?
I mean, probably with.
Which ones do we know?
No, I don't know. Without it being 90, how do we know what we know and what we don't know? Yeah.
Any thoughts?
It's hard without actually
Like the 1%. So since it's on a straight line, it would be half of 360, but then half of that would be the other side. So like either angle.
Say this one more time.
So since that I feel like it's 270 when it's just on a straight plane. It's like an angle like that.
Well, it's 180.
That's 180, yeah.
Yeah.
So and since this is like straight down, would it be 90 on each side?
Oh, here and here?
Yeah. Since
But
this
we
is-
don't know if either of those angles is actually 90. In fact, we could
Oh.
like surmise that it's not.
Okay.
Yeah. But you are like so on the right track here. You are so close. It's something that we know from geometry.
Right, so how.
What about this angle that I made special by having hash marks there? How would we figure out, for example, that angle? I'll give you a clue.
Is it 47?
Here's, yeah!
Oh,
How did you get that?
because I thought about that.
Yeah, okay, good. So, if this is 47,
it's one of
we
those
know
things.
that the opposite angle is 47.
Yeah.
Likewise, if you have two lines that are parallel, you're essentially taking this chunk and setting it over here, where you have the 47 and the 47. Right.
This is pretty.
That's right. Now, convenience of convenience. Eager, bright, young, arithmetic minds. What do we see so fortunately in front of us?
Those angles add up to 90.
They do. They do. That was really nice of them to set the problem up like that. This is a 90-degree angle.
Oh, dope.
Yeah, okay. Cookie's been cracked wide open. Who's ready to go in there for the slam dunk? Mars, you're just racking them up today. I'm giving you two more for that thing. Take it to the hoop. Anybody. Anybody.
Wait, so we're still just
Wait,
trying
who's
to.
Hufflepuff in the house?
No one.
There's no Hufflepuff? Jeez, we should make Owen Hufflepuff.
They don't need more points.
Yeah, no, we need the points.
But Ashley has literally dropped the class. There is no other
But they're
opportunity.
so far ahead right now.
Yeah.
Actually, last time I looked, Gryffindor was actually ahead. Yeah, by a few
Not
points.
to flag.
Not to, yeah, Ashley told me. I didn't. Okay, so.
I haven't looked in a while.
We're like a couple points ahead or something. So.
So now what do? We're looking for
Oh.
D, right? Let's just like Slytherin,
So-
let's take it back to what we're looking for. Like, what's the question again? What is the question? What are we looking for here?
Okay, so. So this is.
I don't know.
So
we
if
know
we
the
have.
question, though.
Wait.
We wanna know,
Oh!
we want to know
wait.
D.
Using something with.
I can think of two good ways to do this. In fact, I can think of four. No, just two. Two good ways to do this.
So if we were using this angle like 90, and we were gonna do like sine function,
Yeah.
trig functions,
Yeah.
this would be the hypotenuse.
D would be correct.
And then what are these two? That's
Well,
I
it
haven't heard
depends. They're either adjacent or opposite depending upon which angle you're interested in
Oh.
taking as your perspective.
Oh, I don't.
Be it, there are 4 ways of doing this, right? There's 4 good ways of doing this.
So, I don't know. I know that like we want to use some type of trig function that includes D and this, or no?
Yeah, 77 and 88. Right? What do we actually have? We don't know what these freaking angles are here.
Yeah.
We don't know what they are.
So we know what this one is and we know what this is.
Right?
So how do we... That's why I was asking which one is opposite and which one is...
It depends. If this is the angle that we're taking as our perspective, then that is opposite and this is adjacent. If this is the angle that we're taking as a perspective, that's opposite and this is adjacent.
Okay, so it doesn't matter which one?
Not to me.
Okay. So we want to do something with opposite and adjacent, so tangent.
Tangent, yep.
Tangent.
Label some of those angles there. I just have them marked as double hash and quadruple hash. Give us some.
Can I do that?
Yeah, make theta 1, put a 1 under it, and a theta 2 under the other. Yep. Nice.
Okay. So theta.
Tangent of theta 1 equals.
Opposite over adjacent. So opposite?
Yep.
Over adjacent?
Yep.
So 77?
Yep.
Over 88?
Nice. So how do we solve that? Anyone else? Help her out. Help a Gryffindor out.
Do you have to put one of these over there?
Well,
Or, I don't know.
77 over 88 is just 7 over 8.
Yeah.
Right?
Yeah. So can
Yep. And, yep. And 7 over 8 is 0.875.
Sorry, what did you say?
0.875.
Oops.
No, 0.875.
Okay. So you just do tangent of that, or no? How do
Yeah. How do we do it? We need an inverse tangent, don't we?
Oh.
Arctan. We take the arctan or the inverse tangent. So we would
Would
go
you just use like? Oh, never mind.
the
Continue.
inverse tangent function. Have we learned how to do that on our calculators yet? Yeah, I think we have.
It's like,
So what you would do is type in 0.875 and then hit the arctangent button rather than the tangent button, and it'll spit out a degree for us.
what does the arctangent button look like? What is this?
It's normally on a calculator. It's like the inverse. There's like the second function goes to the inverse, but on Desmos, Jesus, that's fine.
Okay, let's see. So,
Let's pull this up here.
oh, is it like that? The H?
No, it's that. That's the arctangent.
Okay, so I would type in.
Oh, look at that! I was looking up sperm whales.
875, and then I hit. That's a really big number. Is that okay?
By the way, 0.875. How did I do that so fast in my
Yeah, what the heck? You know, we're just. You're already, like, we're not surprised anymore. You just do crazy things, and we're like, okay.
No, you guys could do that too. $1, what's a quarter of $1? 25 cents.
Oh,
What's
shush.
half
That's great.
of that? It's 12 and a half, right? Half of 25 is 12 and a half. So it's just, imagine 100 minus 12 and a half. So
Oh.
But how did you still do that so fast in your head? Smart man. Okay, I got
you
something.
do it, and you get good at it. Okay, well, we got 40. Write it down. Let's
Okay.
see, and we'll try it here.
Okay.
On Desmos, I think this is how you do it. Oops.
Shoot. Keep writing the ugliest one.
I think this is arctangent. We're going to find out. Is that right? That can't be right. Oh, wait. I need to get it in degrees. Yeah. So Desmos tells me that it's 40.36, and your calculator got 41. That's a little weird, but that. Oh, I did 8.5. It should be 8.75. That's right. There we go.
Yeah, that's actually.
Sweet. All right. Yeah.
Wait, so, yeah, let's go back. Let's hang out. So I just solved. What did I just solve? This?
You solve for theta 1.
Okay,
Yeah,
so now we
what's
know.
up? You got theta 1.
So now we know.
Yeah.
Okay.
41.186 degrees.
186.
86.
So now can't you just, like, do we want to figure that out now?
Well, we need D, don't we?
Yeah. So what do you?
There's like a bunch of places we could go from here. Bunch of places. I can think of like
So
one. I can think of 1, 2, 3, 4, 5. I can think of like at least a half a dozen different directions we could go. So don't feel bad thinking creatively, because whatever direction you head in probably will lead you to the answer. Some are going to be more straightforward than others, but there's a bunch of ways to get there.
Oh wait, so this one is 90.
Yep.
So couldn't we just do like 180 minus like 90 minus 41.186?
Completely valid way of proceeding.
Okay, can I put it in my calculator?
Absolutely.
Okay. And now we know what this is. Yeah.
Sure. Yeah. We've got theta 2.
I don't
So
know
we
if
have-
that was important or not. But
Well, I'll put it this way. There are ways of solving this problem that we could use that number, and there are ways of solving this problem that wouldn't have really required that number.
now what?
You tell me. I'm following you. Oh, geez.
Well,
Mars, you are scoring points right now.
Okay. It's because Lance isn't here. He's not pressuring me. That's it. Let's see. So don't we want to use something that like includes this? No.
Totally.
So what do I use to do that?
I don't know. There's a lot of different things you could use. You have like an abundance of options, right?
Okay. We're here. So I could use the 41.
Mm-hmm.
And so I would put like, it would be like,
Pick a trig function.
Right.
Really, pick one. Doesn't matter. Any
okay,
one of them.
sine.
Sine will
So
work.
sine. Okay, so it would be like sine 41.1. Okay,
Yep.
so sine 41.186 equals
Yes.
something over something.
Yeah.
So sine is so opposite over hypotenuse.
That's it. What's the opposite of that angle? 77. Okay,
over d.
that's it. Oh, right. We are there. We have the final equation that we need.
Cool. Okay, so now
Just rearrange it a bit.
Did you do like 77 times the same? Or over? Sorry.
Yep, that's right. 77 over sine equals d. That's right. All right. Now it's all is left is some calculator work.
Let's just do it because I want to feel satisfied.
So sine of 41.1 is like
I have to take it
0.49
out
or
of-
something like that.
Okay, so
0.48. 77 over 0.48 is like 1.8 or something like that. Am I doing that right? No. It's like 180 in that ballpark.
for D?
Yeah. What'd you get?
Maybe I did it wrong. I got 116. 116.
116?
Yeah, I might have done it wrong though.
Let me see. Sine of 41 degrees.
So you would. So should I put that in first?
No, I'm just calculating it first because it's going to be 77 divided by some number.
Right.
And that number,
I just don't know if it messes up in your calculator if you put 77 divided by sine, like 41 sine.
oh yeah, you
So
should,
I'll just do 41 sine and I'll remember the number. So
no, you
41.
can just go inverse and then times 77.
Okay, so I hit the second thing. Okay.
Oh, you don't need to do inverse.
This thing?
You don't need that. Just go, type in 41 point whatever, 186, and then stick the sign of that. Yeah, okay. And then, you did it right. You did it right. I did. My brain is not as infallible as it seems. Where's the inverse function?
Didn't you say it was that?
No, it's this one. Reciprocal. Right? Yeah.
Well, then
And
maybe
then-
you didn't hit that the first time.
And then times 77. You did it right.
Okay. But now I'm worried that this is wrong because you had hit the second thing. So I don't know.
I
if
didn't
that-
hit the second. No, that's right. That seems right to me. Like,
Okay.
so the sine of 41 degrees, if you think about that, so sine of 45 degrees is going to be 0.5, right? Sine of 41 degrees, its opposite is a smaller number over a lot larger number.
What is it? K kilometers or whatever?
Yeah. Nautical miles, K-N.
Or okay, yeah, no.
Yeah, all right. So let's see if we did this right. 77, 88. Did that part right. Jesus, blah, blah, blah. Okay. Blah, 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 blah. They do 22, 88 nautical miles, 77. They get all that. C, distance from point A to point B. And, oh, they just use the Pythagorean theorem. Ah.
Wait, where? How? What information did they have to do that?
They had this length was 77 and this was 88.
Yeah.
We know it's a right triangle, so a squared plus b squared equals c squared.
That would have been so much easier.
It would have been easy. Would have been easy. Well, let's see what they got with their method. 120 nautical miles.
So we weren't too far off.
No, we were fine.
Okay.
We were fine.
Cool.
Okay.
What's a nautical mile?
A nautical mile. Yeah, a nautical mile. That's a great question, and I'm going to give you a mediocre answer.
Okay.
A nautical mile. The definition of a nautical mile has changed over the years, but it is it's the distance. It's essentially a mile over a curved surface on the water.
Oh. So you count the curve.
Shit. Let's get a definition. This is what the internet's for. I have looked this up a number of times and I never remember it. I'm not a sailor. Define nautical mile. It's actually pretty difficult. It's a unit measured in distance at sea equal to approximately 2,025 yards. That's not helpful at all. Nautical mile. Nautical mile is a unit of measurement, air and marine navigation. Is defined as 1 minute or 1/60th of a degree of latitude along any line of longitude. Nautical mile is defined as exactly 1,852 meters, about 1.15 miles. Derived unit of speed is knot, or 1 nautical mile per hour. Yeah, it's just like a 60th of a degree of latitude.
Is it because like the? I know this has not much to do with truth, but it's like wow, that was
Yeah,
intense.
you are electric today.
What's up with that? So like the surface of the water is like, or the surface of the earth is like this.
Yeah.
Well, more or less. So it measures like this actual distance rather than like, how do I? You know, like typically you would measure
Yeah,
like that.
but a mile,
Yeah.
right? A mile is still a mile on a curved Earth.
Right.
What it is it's if you imagine that
Oh.
there are 90 degrees of longitude or latitude between the equator and the North Pole, right?
Okay.
And if you take one of those 90 degrees and divide it up into 1/60th,
Mm-hmm.
that's a nautical mile.
Strange. I didn't even ask the question as to why.
Well, the Wikipedia talks all about it. I've read it a couple times, and I still don't. I can't
You can't.
regurgitate it. Yeah, I don't really need to use that much. But for people who like to sail, any sailors in the house? Any people who are open to the idea of being a sailor?
I mean,
Yeah.
Oh, well, I go on the boat, but I wouldn't want to control it.
Yeah, maybe this sounds so
So
bad.
no,
I like the aesthetic. I'd be
Yeah,
like,
I was saying.
I got a dinghy. I got a dinghy this year. Am I running out of time a little bit? I got a dinghy in the fall. Remember when I like disappeared?
Yeah, I remember that.
Yeah, remember I disappeared and I went far away and came back with a dinghy, and it's like this little boat that would be like from here to that chair, and it's got sails on it, and I want to learn to sail. Maybe I don't know. Maybe I can get Heather to let us take it out on the lake and go sailing, so we can do some trigonometry, some bearings.
see, that would
Yeah. That sounds fun
At
to
the
me.
camp my family rents, well, we rented from another family that my dad works with, but they have, it's pretty much a dinghy, like it's like a small little boat, and they put a motor on the back of it.
Yeah.
And every time we go to the lake, my little brother always wants to, like, some lakes have, like, motor rentals where you can, like, rent boats for the day. My little brother always wants to do that. It wasn't, like, a real motor boat, obviously.
Yeah.
But he thought it was so cool, and we were, like, going all around the lake with it. And I jumped off some.
Jumped off some. You boated to the rocks and jumped off the rocks. Good.
Wow. That's fun.
Because I'm going to tell you a story of misdeeds that your story is reminding me of. When I was a little younger than you, I was 14. I was on a motorboat in Lake St. Clair in Michigan, one of the Great Lakes, and I jumped off the motorboat instead of a rock, and we're going real fast, and it was like a bad idea. And the boat came around to get me, and it caught the leg. Like I have like a really.
That's my biggest fear.
I have a spectacular set of scars on my leg. I don't know if you guys ever seen me in my togs, but I've got like a really maybe at field day when you see me running around, I'll show off my.
Wow.
Don't jump off of boats. Those motors are really dangerous. Okay, I think. Well, yeah, it's like 2:40 now. So how about before we get to circular functions, forget it. Let's skip that. Let's start with the question that I started class with. Let's end with the same question. What could we do with what we learned now? The things that like I didn't teach you any new math. I just taught we used the same math that we've been learning, and we figured out different ways to apply it. Right? Figure out where an airplane is, how far away an airplane has gone. Figure out how far from base a boat has sailed. What are some other ways we could use that bearing, like the idea of bearing and angles and direction? Is there anything else? I don't know. I don't have something in mind. I'm seeing what's in your mind.
Like activities we could do.
That too, even better. I was just thinking of like, what kind of situation could you use this in? Having, we're talking about directions and bearing and that kind of thing.
Again, like we were saying, sailing.
Sailing. What other instances might you use this kind of stuff?
In football, they do that thing where they like make the.
That's about how much I know about football, but sure. That was a
That's about all I got.
Yeah,
little
like for any kind of like airborne sport, where like you're throwing the ball, you have to know like
angles.
yeah.
Yeah. What are some other? Do we have to be airborne? Don't have to be though.
No.
No.
I guess like, yeah.
What is? Has anybody ever gone camping, hiking? What's like a typical thing you bring with you?
A tent.
A tent. Yeah,
I was
tents
gonna
are
actually
fun.
say that. But
I was thinking compass.
Yeah, that's what I was
You
thinking.
know, guys, it's really smart.
That's what I was thinking. But
You're the
you know,
smart girl.
these are very practical people.
I know.
It's time to
I actually know the answers to all the
But I mean,
questions.
I want to take a nap.
So should I.
Yeah.
Always.
Yeah. Okay. No, orienteering with a compass. I'm walking 23 degrees west of north right now.
Or
Right?
like in all of those movies when like there's a cute boy that comes on and you're like, cute boy at 3 o'clock, you could say instead, you could be like, cute boy at like 73 degrees.
Oh yeah, that would be like some nerd level. Yeah. Whoa.
That's so
Cute
good.
boy at 73 degrees west of north.
Yeah.
What?
Yeah, there you go. That is going to be a line in the show, I bet.
Yeah, that's good. All right, well, if it wasn't super duper snowing, maybe we could go out and do an activity, and maybe we could do it anyways next time. You guys want to run around in the snow? Should I do that? Or you want to stay in here and do this?
Well,
I have a
let's just
fun
prepare.
activity.
Okay, let's just decide if we are or not before class.
That's what I'm.
Yeah.
Yeah, and then we can go.
Yeah.
Do you want to
down
go
for it.
outside and do something, or do you want to just keep talking?
But then
about
we
it?
have to bring like. Well, then I'm gonna feel the need to bring like one photo. I got really bad circulation, so I can't come with like normal socks. I need to wear like special shoes and socks.
Oh, jeez.
It's really bad.
Yeah, my mom's like that.
hands like turn white and like go.
It's
I'm-
called
mine's with my
Raynaud
feet, not really
syndrome.
with my hands.
Yeah. I wish why can't it just be spring all the time?
I love spring.
Just like turn it on and off.
When I was younger, I was trying to be like one of those kids who's like, I'm not like other girls. I'm like, my favorite season is the winter. And I'm like, F that. Like, what was I doing?
I love the winter.
No, I love winter too, but I don't know. If I had
Going
kids,
out
There
for
we
a
go.
long time, yeah.
No, I have
So
a
no.
fun activity. It's like drawing in the snow, following compass directions. Do I have enough compasses? Yeah, it's pretty fun.
So should we bring snow here?
Yeah, it seems like there wasn't a lot of will.
Thank you very much.
Yeah, see you on.